In this section, we're going to look at partial integrals and partial integration and double integrals. All right, so we're just going to start with partial integration and practice that part before we do the doubles. All right, so when you start one of these problems, okay, you want to pay attention to your dummy variable. It tells you which variable you are integrating. So if it's dx, you're just integrating x. All right, so integral from 1 to 2y of 2xy dx. All right, so dx tells me I'm just integrating x. So on the x, I'm going to add 1 to it and divide by the new power. You're ignoring the y, okay? And so the 2's would cancel out, and you just get x squared y, and you want to go from 1 to 2y. Okay, if you integrated x, you plug in for x. So I'm plugging in 2y squared times y, and I'm plugging in 1 squared times y. All right, well, 2y squared is 4y squared times y minus, that's just gonna, 1 squared is 1 times y is y, so I get 4y cubed minus, not 1, sorry, minus y. Okay. Alright, let's do the next one. So again, my first thing is I look at the dummy variable. It's going to tell me who I'm integrating. So I'm going 1 to x, 2x squared y to the negative 2 plus 2y. So I'm integrating y's. So here, add 1 to it, divide by the new power. And here, add 1 to it, divide by the new power. So I end up getting 2 x squared y to the negative 1, which I'm going to rewrite in a minute. Here the 2's cancel and I just get y squared. So I end up with negative 2x squared over y plus y squared, and I want to go from 1 to x. So if I integrated y, you plug in 4y. So I've got negative 2x squared on the top, and on the bottom I'm plugging in x. Plus, I didn't leave myself a lot of room, I'm going to plug in an x squared, and here I'm plugging in 1 for y, so I got 2x squared over 1 plus 1 squared. So here, one of the x's cancels. I'm left with a negative 2x plus the x squared. Alright, here, that just simplifies to a negative 2x squared, and I've got a plus a 1. So are any of these like terms? Yep. These two can go together. So I get a negative 2x minus x squared plus 1. Okay. Alright, so let's go ahead. Y to 5y, x minus y dx. And we're going to call that x minus y to the 1/2 instead of the square root. Okay, so now, u substitution. You see those parentheses. U is going to be the inside of my parentheses. And so du, let's think about it. I'm a dx, so I'm only integrating x. So when I take the derivative of this, it's only the derivative of x would just be 1. Okay, and then the derivative of negative y would go away. Alright, so this becomes integral from y to 5y of u to the 1/2, and du is just 1 dx, which is exactly what I had. So if I integrated it, I'm adding 1 to it and getting 3/2, and dividing by 3/2 is the same as multiplying 2/3. So I end up with 2/3 u to the 3/2, and I'm going from y to 5y, but I don't want to make the mistake I made a minute ago. I need to switch that. So it's 2/3 x minus y to the 3/2. In my last video, I forgot to switch it back and I had to go back and erase. Alright, so let's plug in. I don't know that I have enough room to write, but I'll try. Alright, 2/3. If you integrated x, you plug in for x. So it would be 5y minus y to the 2/3. And over here, it's 2/3 y minus y. Oh, I got that exponent wrong. 3/2, sorry. 3/2. And over here, same thing, 3/2. Alright, well this parentheses is not bad, because what is y minus y? It's 0, and 0 to any power 0 times that 2/3, that's going to go away. So just need to fix this one. So it's 2/3 times 4y to the 3/2. Okay, so it's 2/3 times 4 to the 3 halves times y to the 3 halves. Okay, I can't do anything with that y to 3 halves, but I certainly can do that 4 to the 3 halves. So 2/3, 4 to the 3 halves would be square root of 4, which is 2, and 2 cubed, which is 8. And then I have y to the 3 halves. So I end up with 16/3 y to the 3 halves. Alright, so now integral from 1 to y of, hold on, I want those parentheses in there, 4xy plus y cubed dx. Alright, so again, pay attention to that dummy variable. It tells you integrate x. So add 1 to it, divide by the new power. Now, when I get to this y cubed, it didn't have an x to start with, so it's just kind of like integrating a number. It's a constant. So to integrate it, you just stick on an x. Okay, so this becomes 2x squared y plus xy cubed from 1 to y. So let's plug in. So I integrated x, plug in for x. 2 times y squared y plus y times y cubed. Alright, and here I'm plugging in 1. 2 times 1 squared y plus 1 y cubed. Alright, so if I do the math out, that's 2 times y squared times y, which I'll combine, and that's y to the 4th. This is a negative 2y, and if I distribute the negative, a negative y cubed. So I get 2y cubed plus y to the 4th minus 2y minus y cubed. So I have like terms here and here. So I've got y to the 4th plus just 1y cubed minus 2y. And there's my answer. Alright, so now we have our last three, which are double integrals, okay? So for double integrals, what you're going to do is split it. You're going to do the middle first. You're going to split the integrals, and you're going to split the dummy variables, okay? And just take that part out and say, alright, first thing I'm going to do is just this one. Okay. Alright, so I take the middle out, and I look at my dummy, and it's a dy, so I'm integrating y's. So if I add 1 to it, divide by the new power, and it integrated just a 3, I add on a y. So this ends up as xy squared plus 3y from 0 to x. Okay. So now you integrated y, plug in for y. So x squared plus 3 times x, and then zeros here. X times 0 squared plus 3 times 0. So that one goes away. And so this one I'm left with x times x squared plus 3x, or x cubed plus 3x. When you do this first integral, you should end up in only x's or only y's. And whatever you end up should match the dummy variable that you've got on the outside. And if it doesn't, you messed up somewhere. So now you go grab the integral from the outside, which is 1 to 2, what you got left over, and it's a dx now, which is perfect. This should match the variables you got in here, and you know how to do this. Add 1 to it, divide by the new power, add 1 to it, divide by the new power. So we get 1/4 x to the 4th plus 3/2 x squared from 1 to 2. And y'all will have to forgive me. I did not bring my calculator, and I should have, so I could do these quickly, because I don't really have time on the video to do this. Okay, so 2 to the 4th is 16, and 16 divided by 4/4 of 16 is just 4. Alright, 2 to the squared is 4, and so that's 3/2 times 4 minus, we got a 1/4 and a minus a 3/2. So I got 4 plus 6 minus 1/4 minus 3/2. Alright, so that's 10 minus 1/4 minus 3/2. Or if I put everybody's denominators of 4, 40 over 4 minus 1 over 4 minus 6 over 4. And so I get 33 over 4, and I apologize if I did anything stupid or wrong in there. I just was trying to do it quickly. Should have brought my calculator. Alright. Here we go. Same thing. This one looks way worse than it is, by the way. So again, you split your dummy variables, you split your integrals. So integral from 0 to square root of 1 minus y squared of negative 5xy dx. Okay, so my dummy's dx, integrate x. So add 1 to it, divide by the new power. So end up with a negative 5 halves x squared y from 0 to 1 minus y squared. Alright, so it looks kind of funny, but watch what happens when we plug it in. Okay, so in for x, I'm plugging in the square root of 1 minus y squared, and I'm squaring it. It's going to cancel each other out. And then here, I've got negative 5 halves in for x. I'm plugging in 0 squared and y. So 0 times anything, that's going to go away. So like I was saying, this square root and that square cancel each other out. So I'm left with a negative 5 halves times a 1 minus y squared times a y. So let's think about that as negative 5 halves y times 1 minus y squared. That's a little bit easier to see. You're going to distribute the negative 5 halves through the front and the y through the back, so let's just write it like that. So we got negative 5 halves y plus 5 halves y cubed, right? Okay, so now go grab the 0 and the 2 from the outside, grab what you just got, and it's a dy. So we can integrate this, add 1 to it, and divide by the new power, but dividing by 2 is the same as multiplying by half. And here, add 1 to it, and I get 4. Divide by 4 is the same as multiplying by 1 over 4. So I end up with negative 5 fourths y squared plus 5 eighths y to the fourth from 0 to 2. So again, I apologize, I do not have my calculator. Negative 5 fourths times 2 squared plus 5 eighths times 2 to the fourth. And when I plug in zeros, that one's going to go away. So let's do the math here. So it's negative 5 fourths times 2 squared is 4, plus 5 eighths times 2 to the fourth, which is 16. If those cancel, that's a 2, so it's not near as bad as it looked. I get negative 5 plus 10, or negative 5. Okay. And then our last one. Alright, when they both have numbers in it, like that 7 and that 3 on the inside, these are much easier. Alright, integral 3 to 7 of 4x dy. Alright, so I'm integrating with respect to y. I don't even see a y, so all I have to do is add 1 on. 3 to 7. Now be careful. You integrated with respect to y, you plug in 4y. So that's 4x times 7 and 4x times 3. So I end up with, what is that, 28x minus 12x. And that's going to give me 16x. Okay, so now I'm integrating from negative 1 to 5, 16x dx. So add 1 to it, divide by the new power, end up with 8x squared from negative 1 to 5. 8 times 5 squared minus 8 times negative 1 squared. So that's 8 times 25 minus negative 1 squared is 1, 8. Alright, so 25 times 8 is 16, 70, 90, 20. 200 minus 8, or 192. Alright, so go practice your math lab.